Hi, we're going to do an example of RL circuit. Okay, so this question asks to find the voltage through this 9 ohm resistor. So I know that the voltage is going to be in the form of 9 times IRT. And IRT will be in the form of A e to the power of negative t over tau plus B for the LR circuits. It's going to have the same time constant as seen by the inductor, just because there are no dependent sources in the circuit. So we calculated R equivalent in another video, and I'm going to link that in this video description. Since we have REQ, we can calculate negative 1 over tau to be negative L over R. Wait, it should be L over R. So R over L, sorry. Okay. And in this case, it's negative 550. Okay, so now the rest for us to calculate is just the constant A and the constant B. For that, we need to find the boundary conditions of the circuit for the voltage through the resistor. I'm going to look at the voltage immediately before the switch was closed and the voltage a long time after the switch is closed. So let's do that. Okay, so at t equals to 0 minus, before the switch was closed, this doesn't exist. Okay, and because the switch has not been touched for a very long time, the inductor is going to get short-circuited. Yeah, so basically, we can find VR through a simple mesh analysis. So we have I1 here, I2 here, I3 here. Obviously, we're not going to have any current flow through I3 just because here is a short circuit. We can also see that by doing the simple mesh analysis on I3, and we will find that 15 I3 equals to 0 gives I3 equals to 0. Okay, so all I need to do is to do a super mesh around I1 and I2 because there is a current source in between. So I'm gonna write out the equation for the super mesh. Let's go in this direction. We have negative 13 plus 10 I1 plus 9 I2 plus 8 I2 equals to 0. And from the current source, we know that I2 minus I1 equals to 2. Okay, so solve for I2. I'm not going to solve for it here. Anyways, we have two equations and two unknowns. So we have I2 here. Our VR in this case, t equals to 0, would be equal to 9 I2. And we have this value as a constant. Okay. And then let's look at the circuit when it hasn't been touched for a very long time after the switch was closed. So similarly, the inductor is going to be 0, to be short-circuited, not 0, because it hasn't been touched for a very long time. And let's close this as well. Okay, so this is t. I want to use pink. T equals to infinity. Okay, the circuit is also most easily calculated through a mesh analysis, or actually, let me see, 1, 2, 3, 4, 5. Yeah, there are 5 nodes and 4 meshes, so it's easier to calculate through a mesh analysis. Okay, so let's do that. This is t equals to 0. Okay, let's do t equals to infinity here. I1, I2, I3, and I4. In this case, I4 is not going to have a current of 0 because the equation is different. Just putting it out there. Anyways, so we still have that current source. I1 minus, I2 minus I1 equals to 2. And then we have the same super mesh equation. Just negative 13 plus 10 I1 plus 15, I1 minus I3. And, oh, I think I might have left out a 15 I1 here. Okay, sorry about that. Plus 9 times I2 minus I3 plus 8 I2 equals to 0. Okay, and then let's do mesh 3. We have 9 I3 minus I2 plus 15 I3 minus I1 plus 6 I3 minus I4 equals to 0. And mesh 4, 6 I4 minus I3 plus 9 I4 equals to 0. Okay, so we have 4 equations and 4 unknowns again. 1, 2, 3, 4. So I can solve for all of the unknowns. And my VR would be equal to 9 times I2 minus I3. Perfect. So this is the VR at infinity, at time infinity. Okay, let's pull out our template for the voltage equation again. So VR equals to 9 times a e to the power of t over tau plus b. And tau, a negative I1 over tau is just negative 540 t. Okay, so at t equals to 0, this equation equals to 9a plus b. And we have that value here. And we assume that we solve for the system of linear equations and that we do have that value. So it's going to be something that we know. Okay, and at t equals to infinity, VR infinity will be equal to, since t equals to infinity, this is going to be very largely negative. So this term goes to 0. So the equation is going to be 9b. And we also have this value, which we've calculated here. Okay, great. So here, again, we have 2 equations and 2 unknowns. So just solve for A and B, and our final formula will be plugged in here. The final answer that I got is this. So make sure to try to solve them and check the answer for yourself. Okay, great. Let me know if anyone has additional questions.